Okay, good morning. So I welcome you all to the Department of Mechanical, where we are hosting AICTE Idea Lab program for the students. It's a skill development program on designing and prototyping. Okay, so basically the skill development program enhances the skill set of the students who are willing to excel themselves in various aspects of design, development, prototyping, making and product development. So at this juncture, I would like to tell you that this program will not only help you to develop your ideas in designing, as well as it will also give you enough impetus to develop prototype and to make realistic products. So I'd like to welcome my co-coordinator of this AICTE Idea Lab, Professor Devdatta Ghosh. Along with me, I have my technical gurus of this Idea Lab, Dr. Ashim Haldar and Professor Dipendu Chaudhary. And the logistics are being supported by Mohan Patro. And with me I have a student volunteers of ME Club. So at the outset I would like to request Professor Devdatta Ghosh to say a few words to initiate the program.
Good morning. So I'm just wondering that out of 47 registrations, I can see how many? 20-25 pairs. I don't know how it is getting controlled. Some more students are coming. So actually the plan was made in order to enhance our students towards the prototyping by organizing two programs, two skill development programs between 21st to 27th, right? Hopefully we are starting the phase 1 today. So initially we are not adding some elaboration on these programs. Straight away we are coming to the point where Idea Lab will play a major role. Let me tell you little bit in the elaborate way what this Idea Laboratory is. This is the brainchild of All India Council for Technical Education. Last year, they have given Idea Lab to 70 institutions. We are one of them. In West Bengal, there are 3 colleges where Idea Lab was already set up. So what is the objective of this kind of laboratory? This laboratory is centered around certain activities in order to enhance the skill of the students, so that ultimately they can go for entrepreneurship and can go for a startup also. So if you go for entrepreneurship or startup, prototyping or product development is one of the major points where you have to look at. We are technological guys, so whatever we offer in terms of service or product, that should be coming up with the technology. So that's why from the beginning we have tried to enhance the skill of the students, not only students. We have tried to enhance the skill of the faculty members. We have tried to reach the school students, try to reach the school teachers, industry, different segments of the society. So this is not a laboratory as such. This is a kind of technical movement which AICTE has initiated and we are part of them. So in this particular note, we are also starting the skill development program. I think for the 7th time we are going to organize this, and this program will be started with the lecture of Dr. Gautam Ghosh. He is our coordinator, For 2 days, you will be lecturing in the morning. Second half, you will be available in the laboratory. You will get practical exposure there. Since the time is short, so you will go for prototyping, product development on paper. If time permits afterwards, we will do it practical. Because within 3 days, it will not be possible to go for a real-time product development. Let's see how much you can take. Let's see your interest towards this particular topic. Because this is all about mechanical engineering and electronics engineering. To some extent instrumentation, Internet of Things, embedded system. And if you take all these things together, it's a kind of mechatronic system, okay, which we are coming up with. So that's why let's see how much interest you have, because this is not within the syllabus. You are not going to get marks for this. In your marks, nowhere it will be mentioned. But the intangible knowledge which you will gather here, probably it will help you in your future. Thank you very much.
Okay, sir. It is very nice to hear from you with those enlightening words. So now I'd like to request Dr. Ashim Haldar to say a few words.
Good morning, students. And coordinator and co-coordinator of the AICTE Idea Lab. Students, we are the technical gurus, more technical gurus. We are here. Here you are going to get the training to develop a prototype. Okay, this is a training program where we are going to help you. So, as you can see, it is the Idea Lab. After this training, if you have any kind of ideas in your mind that can be visualized, or the prototype or the instruments you can design in this Idea Lab with the help of these 4 technical groups. Okay, so students, welcome you and thank you very much for attending this skill program.
Okay, Dr. Haldar, it was very nice to hear from you. Now I'd like to request Dr. Shiru Banerjee, who is also a tech guru from mechanical department. I request him to say a few words.
Good morning, everybody. So, welcome to another program of Idea Lab. So, you must be eager to when this main program will start. So, I will not take much of your time. So, as throughout the process, you will understand the importance of design to prototyping, and it is very essential for students to kind of do hands-on. So, whatever you are kind of going through some theory, you have to do hands-on and you have to follow a link between what you are reading in the books and what you are actually doing. So either of them alone will not help you make a complete engineer. Okay. So if you just kind of love to read textbook and you know how to solve the design problems, okay, so that will also kind of leave some way behind when you are in the practical world, how to approach those problems, how to solve using different tools. Okay, so that needs to know. Similarly, there are another thought process that goes among the students that okay, there is no need to go to the textbooks. We will go directly and we will do whatever we will get software knowledge. We will have the machine, we will operate the machine. So you are not the operator, you are the engineers. So an engineer should have an ideal blend of both theory and practice. So this particular course, this particular session will help you inculcate those kind of skills into you. So I hope that it is really helpful for you. All the best. Thank you.
Thank you, Dr. Shiru Banerjee. So now directly we will be starting the program. So we have planned the entire program. Like in the first half, most probably there will be lecture session, and in the second half, we will be directly taken to the Idea Lab for hands-on experience. and we will have the practical exposure. Okay, so initially we will be dealing with some of the theoretical stuff in the morning, and in the post lunch session we will be giving you the exposure on how the different equipment that we are having in the Idea Lab works, and some minor projects will be given to you for your practical exposure. So basically in the Idea Lab we have 3D printing and scanning systems, we have CO2 laser cutting system, we have wood cutting router, we have PCB milling machine, we have an embedded system with IoT enabled products. Okay, so these are the basic domains of Idea Lab. So you can choose some of the different domains according to your own choice, or when the projects will be given to you for performing the different works. So as of now, we'll start with the theory, and then in the post-lunch session, you will be taken to the Idea Lab to see the various facets of Idea Lab and hands-on experience. Okay, thank you very much. Time is the only factor which determines the existence of that company. Okay? If you are not going to deliver the product in time, someone else will. So time is the only factor in the company or any industry which determines its existence. Okay. Now over here, what we will be dealing with is development of prototypes. How quickly we can develop a prototype. So now you know 3D printing is a technology which can be either used for development of prototype or it can be used for development of actual products. Both can be done with this technology. How? For making prototypes, you can go with polymer materials which are easily available and which can be molded at a very less temperature, cost is less, or we can go for actual product through metallic printing. Let's say you want to make a gear. So the exact gear can be 3D printed in metallic 3D printing machines. Okay? So those are the actual products which are being made. It's not a prototype. It's 3D printing. And prototyping is you are making the exact replica. You are making a gear, but not with metal, with polymer. So it is prototyping. So these are the two fundamental things you should remember. 3D printing and prototyping are not same. 3D printing is making actual object which can be readily fitted as a component or a product for practical use. And prototyping is making the replica of that product, and it has a resemblance with the original object, but it is not the original object. Okay, it's a prototype. So we will be dealing with prototypes, but the technology is same. Whatever method you are using, whether you are going for 3D printing or prototyping, the method is same. Method of manufacturing remains same. Okay. So these are some of the contents we will be dealing with: terms of reference of definitions, capabilities of additive manufacturing, geometric capabilities and material capabilities. Geometric capabilities means what are the geometric aspects which has to be considered, what are the different types of materials that should be considered, and the classifications of additive manufacturing with respect to American standards and the raw material that we'll be using for manufacturing. So these are the terms of reference. 3D printing, the term which can be used for making products which are actually used in different aspects of, let's say, in all the aspects, all the design aspects, all the material aspects, all the safety factors, okay, all the tolerances, everything we incorporate in the design. And after that, we validate the design through simulations. Through simulating software, we validate the design. Okay, dynamic stress, static stress, okay, then the thermal aspects, everything we simulate and test the design in the software. Then finally we make a prototype of that design, the exact replica. Because you know, when you are making an object and when you are designing it in the virtual mode, obviously now you have the VR mode. So it will give you a virtual feeling of that object. But what about the real feel? Okay, so real feel is you need a prototype physically, which has to be physically developed and physically verified. So when we are making a physical product, which is the exact replica of that product, it gives you an impression and it gives you an elaborate decision making which can be readily used for the purpose which it is intended. Okay, supposing a gear, you are manufacturing a real gear through metallic 3D printing and directly you are applying in the area where it is applied, in the gearbox or somewhere else. Okay, so that is 3D printing. And in rapid prototyping, we are making the prototypes with basically non-metallic substances. It can be polymer, it can be ceramic, it can be clay. So these are the substances with which we make prototypes, which are cheap and which can be molded in the shape of an object so that we can see and visualize the features of the actual object, which is a prototype. And after visualizing the object, you can decide on the changes if required. You can go for modifications, you can go for some upliftment in the aesthetic level. Okay, that's what prototype is for design. So it's a process of joining materials to make 3D objects in rapid prototyping or 3D printing or layered manufacturing, whatever name you call. It is basically addition of layers of materials, accumulating in a sequential manner, one after another, and taking a 3D profile. You are depositing layers in a sequential manner, and then the layers add up to give a 3D impression or a 3D profile of an object. That's what we call additive manufacturing. It's addition of layers in a sequential manner. Now in this case, the addition of layer will take place depending upon the layer thickness, which has to be predefined. The amount of layer that will be deposited depends upon the thickness of layer you have pre-assigned. Whether it's 1 millimeter or 0.1 millimeter, that depends upon how much of the layer you want to deposit every time in a sequential manner.
So hope all of you install in your computer or laptop the software which is called AutoCAD Learn. So you open your laptop and open this software that is Evolve. So where we try to design this circuit which is called stable multivariable circuit. This circuit maybe you covered in this semester in analog circuit, analog electronics subject. not completed yet. So right now I have not discussed the working principle of the circuit. Just go to the software. So first you click
Special thrust on soldering process, which is very much pertinent to electronics and every department. Those who are working on microprocessors and microchips. Okay, so soldering is an important aspect in this regard. So we will be taking lectures on embedded system and special thrust on soldering systems, processes of soldering. Okay. So I request Professor Jindal to continue his lecture.
So actually, is in this kind of skill development program, we cannot give you the total coverage. It's a total coverage from prototyping to product development. But yes, what we are trying to do is the first version will tell you, give you all the inputs, which will subsequently help you in the next skill development program to go for product development, actual product development. Let me tell you one more thing. During your tech test, there will be one event organized by Ideal Lab. The event name is Itathon. Itathon. So in Itathon, we have given you some task areas where it would be absolutely thing based. Theoretically, you have to think about a product development. And if you are selected, you will be getting the opportunity to work with the Ideal Lab, where you will get all the support for making your product. Alright? And it will come up with a take test very shortly, which is going to be organized. Secondly, I am supposed to talk about the embedded system today because with the additive manufacturing, we thought this is one of the essential components as far as Ideal Lab is concerned. But during product development, in the previous faculty development programs, or in the skill development program, or the ideation workshop which we have already organized, we have seen there are some missing links. Why it is so? Because specifically, if you look at the syllabus, there is no coverage about the software. You have learned, you have started studying how to make these. One of the way we are disclosing that at this moment, we are not talking about the milling machine. Subsequently, in the next skilling program, we try to train you how to make pieces with the help of this milling machine with the use of even software. Yesterday, I hope you have got the fair idea about this. But after PCB is made, the next step is fabrication. How to put the components. We have seen in many cases the soldering is found to be very simple, but it creates huge problem at the time of product development. In most of the cases we have seen, even last 2 days, we have to spend in finding out the points in the PCBs. It is nicely made, it is soldered, but without having that skill properly, if you do that, in most of the cases, it will be a problem. We have not seen a single product which was hassle-free in terms of soldering. So before I talk about the embedded system, which is basically informing, there is no such logic. The concept which we already had will be accumulated together in embedded system. Okay? At least if you do not have the good idea, but you have the continuous user of the embedded system. Finally, we will end our lecture with that. So what I will do is I will just disclose the acts of the software as far as possible in the theoretical class. so that at least I can provide you the lead which will please your skills. Because if you go for product development where mechanical, electronics, embedded system, instrumentation comes together, then it is essential to fabricate the components, and we do not have any facility where you can go for automatic sorting. And at this level it is not required also. In the industry, they go for hand sorting. So today I talk about hand sorting first. Then I talk about some of the essential test measuring instruments which we have to use regularly during the fabrication process, during the development process. Because if you simulate a circuit with the help of circuit maker, spice, anything, when it comes to the practical, it gives lots of problems. And there is a huge gap between theory and practical. And there comes the effectivity of the learning by people. So some of the facts I disclose, just you try to remember the terms. When you will be working really in the laboratory, just recollect those information and try to do it. Try to follow the recommendations, right? So, the soldering will have certain coverages. Like I'll give you overview. The minimal number of tools which will be required for soldering. Some associates, some of the safety measures you have to take. How to solder, best practices and practical application. Those who are from mechanical, I don't know how many of you are from mechanical. So, always a question may raise in your mind: what is the difference between welding and soldering? Right? But it's not welding actually. Welding methods are totally different. Though technically they looks like same. So it's not a welding; it's a basic kind of welding, where solder, wonders, and low melting temperature we use. It heats up and melts the solder. Means what we do, the component which is fabricated or inserted in the PCB has to be soldered so that metal to metal junction is developed. Otherwise, there will not be any corrections. The idea is the copper layer which you have made through your PCB making process has to be connected with the component leads. Right? Join wires, PCBs and electronic components. As I told you, this is a typical soldering iron. There are many varieties. This is one of the varieties. Okay, with a typical tip, and you can understand the principle. It gets heated, right? And like really hot and gets components hot, will get you when the components are heated and soldering material melts. So in this junction, you have to put the materials there in order to perform the soldering. And afterwards, I talk about soldering station of little bit. The soldering station broadly of two types. One is temperature control, because in some of the cases we need to maintain the temperature. We should not go beyond the threshold limit. And the time of contact is also very important. So some of the soldering machines are coming up with these specimens. And this kind of soldering machine doesn't have that kind of control. Right? It's not a soldering station, but it's a soldering iron. Right? These are the typical tips of the soldering iron. This is one kind of, right? So tips and sizes are changeable. This is the soldering material we use. Okay. And it builds and gets deposited there in order to connect the components with the PCBs. Okay. And it has got different gauges depending on the component, depending